Now we've got a juicier question. Oh, just something to note. This caret just means squared. It's just because I was typing these out, so it looks a little wonky. All right, so now we're at a fun one. Here we have vertex form, and then here we have standard form, and we have to convert between them and figure out what's going on. So this is kind of fun. Notice that our A value is the same in both, which is good, it should be. But we can't assume that C is going to be 10. It probably isn't. So what can we do with something like this? Well, whenever we have a question like this, where we have to find equivalent expressions or something, we basically just want to expand stuff and move stuff around until this side looks like that side. When in doubt, just expand stuff, foil stuff until it looks more like the thing it's supposed to look like. So let's do it. I want to be very careful about this 4. Remember your PEMDAS, your please excuse my dear Aunt Sally, or whatever they call it these days. Parentheses, exponents, multiply, divide, add, subtract. So your exponent is going to come before that 4. So keep that in mind. All right, let's expand this fella. Well, I remember that x plus a squared was equal to x squared plus 2ax plus a squared. So that's going to save me a little time, so I don't actually have to FOIL it. I'm going to keep this 4. And I'm just going to do, okay, so x squared plus 2 times 1 times x. I'll just write that out so that it is more visual for you guys. I wouldn't actually write 2 times 1 in my own notes. And then plus a squared plus 1 squared. And then plus 10, I don't want to forget it, so I am not going to leave it out a single line. If we leave things out and then we're like, oh, we'll come back for that 10 is, we're going to forget. And that 4 as well. All right, so, okay, so 2 times 1, obviously that's just 2. So I'll just write that 2x, and then 1 squared is obviously just 1. So I'll just get rid of that. So this is 2x. All right, now I can distribute. So 4, I'm going to draw my little lines. I draw my little lines. I recommend drawing your little lines as well. All right, so 4x squared plus 4 times 2, 8x. If I make any errors, call me out, but should be right. 4 times 1 is 4. And then that is going to match up with this side now. It looks right? This is like our ax, bx, c. 4x squared plus bx plus c. And now it's like, oh, wait, okay, this kind of is looking similar. We've got our 4 with our x squared, which is good. We've got our 8 with our x, so b is 8. B is 8. And 4 is C. C is 4. All right, now let's go to the end of the question to see what we're actually looking for. The end of the question for math is practically always where it tells you what you actually need. Do you need x or do you need x minus 1, right? Check. Find out at the end of the question. All right, what is b plus c? 8 plus 4 is 12. Done. Should be right. All right, so what did we use to get this? We used basically this. This was helpful. We didn't need this because we could have just foiled this, but it saved time. We used our understanding of standard form versus vertex form. We didn't actually have to find the vertex here, but we did have to understand that that 4 is sort of a guide for us, and that everything else just fell into place from there. We had to use PEMDAS as well. And we had to remember to check the end of the question to see what they're actually looking for.